everybody over here, you had warm seats when you came in, because the people that were here. Yeah. All right. Number 9, what type of transformation? And this one was on your foldable. If you do a translation and a reflection, doesn't matter who comes first, what is that? It's a glide reflection. If you have your book, I want you to turn to 585. That was one of the things I asked you to learn. Make sure you knew. So let's look at problem number 11. 9? So 11, you want to reflect across x equals -2. What kind of line is x equal -2? Vertical. So it's going to be somewhere, if this is 1 and this is 2, a -2 is going to x equal -2 somewhere along there. Then you're going to reflect along x equal 4. And again, that's going to be, what kind of lines are these? Parallel. When you reflect over parallel lines, look at page 588 if you have it. I asked you to know this theorem. What is a reflection over parallel lines? It's a translation. If you look at pardon? 11. All right, so now, how do you graph y equals -x? What's the y-intercept? 0. And what's your slope? -1/1. So we start at 0, 0. We go down 1 over 1, down 1 over 1, down 1 over 1. Okay, so this is number 12. So here's our first line. How do we graph? They said y equals x. What is that one? 0, 0, what do we do? Nothing's being added. What's the slope? Up 1 over 1, up 1 over 1, up 1 over 1. What kind of lines do we have this time? Intersecting. You're back on page 585 if anybody has their book open. Theorem 9.2, what does it say when you have intersecting lines and you reflect over two intersecting lines? What is it? A rotation. Does anybody have the objectives, test objectives out? Anybody print them? Or write them? Okay. Did you get the very last one? Anybody have the very last one? I think it's the very last one. Very last one mentions this theorem. Next question. Any other questions on this homework? Yes. 7. A dilation with center 0, 0 and a scale factor of 3. You're supposed to do that to that quadrilateral. So let's look at the vertices of that quadrilateral. Do you agree that vertex A is 3, 0? Vertex B is 1, -2. 7. C is, I think there's a C. C is 3, -5. And D is, this I think took up a lot of your graph paper. Looks like 7, -1. Okay, how do we do a dilation whose scale factor is 3? What are we supposed to do? Multiply every x and every y by 3. So you're going to get 9, 0. Then we're going to have b prime, which is going to be 3 times 1, and 3 times -2, which is going to be 3, -6. Then we're going to have c prime, which is 3 times 3, and 3 times -5, which is going to be 9, -15. And then you're going to do d prime, which is 3 times 7, 3 times -1, and that's going to be 21, -3. And then what do you do to those four ordered pairs? Graph them. And that should be a whole lot bigger than what this was. So you can see that it takes a lot of graph paper. It's a problem with dilations, especially if they're not fractions. Number 4, that is a fraction. Oh, this is the same ordered pairs, correct? Okay, so we're going to do now this. I'm changing this to number 4. Oh no, it's real easy to fix because what are every one of these 3's going to change to? What will each one of these 3's be? We're going to change 3 to what? Carlin? The scale factor is the 0, 0 is your origin. What's your scale factor? 2 over 3. So you're going to multiply this by 2/3 and this by 2/3. You're going to multiply this by 2/3 and 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 this by 2/3. So this is going to be 6/3 or 2, 0. This is going to be 2/3 or -4/3. How do we multiply fractions? Numerator times numerator, denominator times denominator. This is again going to be 6 over 3, which is 2. This is going to be -10/3. Then this is going to be 7 over 1. This is going to be 14 over 3. And this is 1 over 1, so that's going to be -2/3. So if you go to graph it, this needs to be changed to -1 1/3. This would need to be changed to -3 1/3. 14 divided by 3 is 4. 4 times 3 is 12, remainder 2. So that's going to be 2/3. Right there. So this becomes 4 2/3. Okay? So and then you go graph those points. Well, if we want to do, what is it? 2/3 -4/3. Let me grab some graph paper. And this is something, if you had Algebra 1 last year and were at a Carnegie school, that's all they did was fractions. All right. So we'll graph the one we can see. Let's graph 4 2/3 -2/3. So we're going to go over 1, 2, 3, 4 units. That's 5 units, and over 2/3 is over half. So that's 4 2/3, and now we're going to go down, not a whole, but approximately 2/3. It's not an exact science. Not if they're, right. So, what I don't want to see, this just drives me up a wall. Where's the large graph paper? The purpose for graph paper is to be as accurate as possible. And forgive me if I've already told you this, but this is what I do not want to see. What's the use of using graph paper if we're going to do this little number? No. Okay. Now, on the test, it may be 2, 4, 6. What does that mean? What if I'm here? Where am I? Okay, make sure you pay attention to scale. Okay, did you hear me? Make sure you pay attention to scale. All right, next. Samantha. Reflection across y equals, all right, so that's that figure, right? We're still working with the same figure. All right, let me get graph paper. All right, let me try to get our figure on here. We've got 1, 2, 3, 0, 1, -2, -5, 3. I think it was 7, 3, 4, 5, 6, 7, 1, right? Okay, here's our figure to start.
-5, 3.
I know I said it backwards. It was actually 3, -5. I knew my 3. I was looking for the -5. All right, so there we are. We need to reflect across y equals x. So Samantha, how do I graph y equals x? From what point? Yeah, perfect. Up 1 over 1. I'm going to go a long way away so I can do a pretty good line. So that means I need to connect. Now this is what I'm talking about on the objectives of going over an oblique line. Okay? So this is I think this is B, C, D. So I'm going to look at A first. So I have to go, this slope is 1. I need to work with perpendicular slope, which is what? -1, because the reflection line is the perpendicular bisector. So so -1, I'm going to rise 1. Because I went positive, I'm going to have to go left 1. All right. So now I'm going to rise 1, go left 1. Do you agree that this distance matches that distance right here? So I have to go up 1 over 1. That is going to be A prime. This length right here should be, that line should bisect it. So from D, we're going to go up 1 over 1, up 1, 2. Okay, let me, 1, 2, 3, 4. How many do I have to go in the other direction? 1, 2, 3, 4. That's D prime. So now B, we go up 1 over 1, up 1 over 1. That's equidistant there, and I need to go one more up 1 over 1. That's going to be B prime. C prime, up 1 over 1, up 1, 2, 3, 4. So 1, 2, 3, 4. There's C prime. So now I got to figure out what I'm supposed to connect. Maybe I'll do it in black. All right, I know C to D prime. And my A prime is down here. My B prime, I believe, is here. There it is. You need graph paper tomorrow. What else? Yes, ma'am. Glide reflection with the translation and a reflection across x equals 0. All right, I will write it so that you know where to start. I'm assuming that we're going to do the translation, then the reflection. So we're going to take, I think what I'm going to do is I'm going to get the big eraser. Can I erase this now? Are you all good? Okay. So I'm going to get rid of everything here. I'm going to get rid of all of this. I'm going to get rid of this. Okay, how do we do a glide reflection? I mean a translation that says x, y plus 5. What does that mean? It could have, remember, it could have been written 0, 5. What does that mean? So 1, 2, 3, 4, 5. No left or right movement. So this is going to be B prime. 1, 2, 3, 4, 5. That's going to be A prime. This is D. 1, 2, 3, 4, 5. That's D prime. This is C. 1, 2, 3, 4, 5. That's C prime. All right, so after this is where we're at. What am I supposed to do? I translated. What am I supposed to do now? Reflect across. Where is x equals 0? Your answer to this question is incredibly important. It's the y-axis. Excellent. Yes. So we're going to, this point, and it's not the original, it's the new one, is 1 away, so that's going to be B double prime. A is 3 away, so we want to go 3 away in this direction. That's A double prime. 1, 2, 3, 4, 5, 6, 7. So I stay on this horizontal, 2, 4, 6, 7. And then A, this is C prime, is 3 away, so I'm going to come over here 3 away. So this is C double prime. This is D double prime. So my final figure, I'm going to make really fat and red, is this figure. Next question. (13, 14, and 15). On these, we're looking at how many symmetry lines. That was one of the objectives, and I'm going to attempt to draw 13. But my drawing skills are not the best. All right, how many symmetry lines should this have? 1. Where? There. If it was drawn as well as the book, that should be a symmetry line. All right, and it says what type of symmetry. So this has line symmetry. All right, the next one. Pardon? The only way we can rotate that is 360 degrees. And the rotational symmetry has to be 180 or less. All right, so I'm going to clone this. I think they've done something like this. Am I right? On this next one. So the question is, and hopefully that works, depending on how well I did this. So what type of symmetry is this going to have? Rotational. Any other? If I drew it well, what else does it have? Yes, it does have line. I'm having a tough time here. All right, so we're going to pretend. The line symmetry would be where? Do you agree? Mm-hmm. Right there would flip it on itself. All right, so that definitely has line symmetry. If I were to group this, and I were to clone it, I wonder if I can make it a different color. Whew. All right, so the question is, if I were to rotate it, now it's not, and I were to rotate it so that it was on its center point, should it fall on itself if I drew a good picture? It should. The question is, what's the degree of rotation? How many times do I have to rotate it to get it back on itself? 3 times. How many times is 3 divided 1? 360? 360 divided by 3 is 120. So it has rotational symmetry of 120 degrees. If you look at the last one, does it have a line of symmetry? Is there a line of symmetry here? No. No. But what symmetry should it have if I drew it better? Rotational. And what kind of rotational symmetry would that be? It's 180 degrees. And when it only has 180 degrees, it's called point symmetry. Okay, you're going to see this next year in Algebra 2. When you have a function f of x equals x to the 3rd power, that's point symmetry about the origin. It's 180 degree rotation. So these pictures are going to become graphs next year. Other questions? Kayla. 24. It says a dilation with center 0, 0 and a scale factor of 2.5 maps AB onto. Okay, so this is the deal. AB maps onto, I didn't do that very well, 10, negative 25. The scale factor is negative 2.5. If you recall, to dilate, didn't we take this ordered pair and multiply everything by negative 2.5? So if I want to go backwards, what do I have to do? Right. You got to divide 10. That's a division sign. You got to divide 10 by negative 2.5, and you got to divide 25 by negative 2.5. So on a dilation, to go from pre-image to the image, all right, you multiply by the scale factor. However, if we reverse that, this is the pre-image, and this is the image, and we know the image information, we don't know the pre-image information. If I multiply to go this way, what will I do this way? Divide. And that was that question 3 on your dilation quiz.
For those kinds of questions, do you want us to like show you the equation, or like we just get?
I want, if you add, subtract, multiply, divide, I have to see the work. Other questions? Becky. 8. Write a translation that maps P negative 4, 2 onto. Oh, so here we need the rule. So we starting at negative 4, 2, and our end point or our stopping point is negative 1, negative 1. The question is, what do I add to negative 4 to get negative 1? 3. What's negative 4 plus 3? Negative 1. What do I add to 2 to get negative 1? Negative 3 plus 2 is negative 1. So what's your translation rule? 3, negative 3. Here's another way you could do it. Negative 4 plus what number equals negative 1? Solve for the question mark. You add 4. That unknown is 3. Bingo. You can do the same thing. 2 plus what number gives me negative 1? Solve for the question mark. The question mark is negative 3. What's next? Yes. Rotation of 90. To do number 3, what do you need to know? What rules? What rules do we need to know? How many are there? There are 4. So this was your, what was it? This was your rotation quiz. You had to memorize 5 things for me, or 6 things. This is 3, negative 5. D was 7, negative 1. So if I want to do 90-degree rotation, what do we do to these ordered pairs? Switch them and take the opposite of which one? Opposite of X or opposite of Y? Opposite of the first one. Yeah, the old Y. So we're going to flip these, and we take opposite of the first. We're going to flip these. We're going to take the opposite of the first. We're going to flip these. We're going to take the opposite of the first. This should be the easiest question on the test. However, if you don't know the rules, it's the hardest. What is a rotation about 180 of XY? Negative X, negative Y. What is a rotation 270 of XY? Switch them, take the opposite of the second. What is a rotation of 360? Right. 360 means they just fall right back on top of each other. Our rotation of 90 of XY was negative YX. You got to know these. All right, so what if I ask you to rotate in a negative direction? What if I ask you to rotate a negative 90? What is that equivalent to? It's equivalent to 270. And our 270 was switch them, take the opposite of the second. And then a rotation of negative 270 is equivalent to 90. So that means opposite. See, switch them and take the opposite of the first. Yes, ma'am.
Are we gonna be able to keep these for tonight to study? Like,
Yes, and in fact, Leslie, will you go over the responsibility chart and tell me who the paper person is for this week? Hope. I need you to pass papers back from Friday because that is Friday's homework that I promised you'd have back. Okay? We're the red folder over near Jennifer. All right, so I think I'm going to keep this running, and I'm going to introduce you to barn quilts. Okay? Barn quilts was a phenomenon that happened kind of in the Northeast, I believe. There's a barn, and what it is it's a geometric design that has been painted on the barn or actually made out of wood and then put on the barn like it was, like you would hang a painting. And that is what you all are going to do, is you are going to do a barn quilt. So this is a very artistic, creative outlet for those who have that part of you. I mean, there's going to be some beautiful barn quilts. I want this done on graph paper. It will help you significantly to do this on graph paper. Now, this is colored. We don't want to think about the colors right now. I want you to think about it. So I want you to do your barn quilt and not color it. And then you have to describe all the rotations, reflections, etc. Describe the symmetry and the transformations. Okay? So ignoring the fact that it's colored, what kind of symmetry does it have? It has rotational symmetry. All right. So now if you tell me there is rotational symmetry, you have to tell me what is the degree of rotation? 90-degree rotational symmetry. Okay? What else do you see? Reflection lines. So there are reflection lines. So what are your reflection? What are your reflection lines? How many? 1, 2, 3, 4. There are 4 of them. You've got a vertical, right? You've got a horizontal, and you've got 2 diagonals. All right? Anything else? Okay, then you're going to color it. Now, the coloring here does not change any of this. Do you agree? Red falls on red, yellow falls on yellow, green falls on green. You with me? But there are some barn quilts that once they're colored, all of a sudden change. So do you see how this looks 3D? All right, ignore the coloring. Before coloring, let's do this. You know what? It's not very often I can write with a yellow pen. So this is going to be before coloring. What do you see? Line symmetry. Okay? Line symmetry. There should be 2 M's. Where is it? Do you agree there? And here? Yes? Any more? Can you fold here? Can you fold here? How many? Who's counting? There's 3, right? Can you hold here? Fold here? 4. Can you fold here? Yes? 5. What about here? 6. 7. Am I missing one? Is that 8? Okay, line symmetry. It has 8 lines of symmetry. Any other transformation? Rotational symmetry, definitely. Rotational symmetry. All right, what's the smallest degree of rotation? How do I get this point basically to fall on this point? There's 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8. How do you figure out what the degree of rotation is? 360 divided by 8 is 45. So it has rotational symmetry of 45 degrees. That's before it is colored. All right. So now I'm going to erase. Once it is colored, does it have reflectional symmetry anymore? Does it have line symmetry? That means that when you reflect, blue must fall on blue. What will this blue fall on? White. So there's no longer reflectional symmetry here. Is there reflectional symmetry here anymore? Blue would fall on what? White. Is there reflectional symmetry anymore? No. Here is a reflectional symmetry. White falls on blue. So by this coloring, what do we know? That there is no line symmetry anymore. Is there still rotational? Okay, so then you're going to tell me after coloring, there is no longer any line symmetry. However, the rotational symmetry is unchanged. You with me? The rotational symmetry is unchanged. All right, one of the things that you have to have in your picture are two congruent triangles. Would this picture qualify for two congruent triangles? Do I have at least two congruent triangles? Yes. The red triangles would be my congruent triangles. So, and with the coloring, the red triangles would still have line symmetry, but the figure itself does not. And it's okay. It's great that you can change that. So you got to address both. All right. This, afterwards, there is no change in symmetry.
Is 8:40 our homework tonight?
8:40 is going to be due on Wednesday.
Okay.
Okay, I want you to study tonight. So if we look at this before it was colored, what do you have? You do have symmetry, lines of symmetry. What are your lines of symmetry? How many? There's one. Now that's not a symmetry line, is it? Is that a symmetry line? Is that a symmetry line? But is this a symmetry line? Through here? 2, 3, 4. That's the same one. That's the same. I think it has 4. What do you think? Are you seeing something else? Does it have rotational symmetry uncolored? How many degrees does it take for you to go from here to here? So that's 1. And then don't we have to rotate over to here? Oh, I'm sorry. This, forget that. This would fall on here. So, yes, it is. It does look like 90. But let's just double check. This would fall here. That's 1. There's 2. There's 3. There's 4. So it has 90-degree rotational symmetry. Okay? After it's colored, does it have line symmetry anymore? Does it have line symmetry? Do you agree the red pieces do? But if you were to fold on this line, okay. If you were to fold on this line here, do you agree black falls on gray? So that was ruined. If we fold on this line, gray falls on black. So that's no longer. So we don't have the line symmetry. Do we still have the rotational? Yes? All right. There's another barn quilt. Make sure that you've got triangles. You've got to have two congruent triangles, and that quilt's actually on a barn. There's another barn. It was just fascinating up in Pennsylvania. Everywhere you traveled, you'd see these on different barns, some on houses. So you're doing a barn quilt for your house. There's another one. I mean, let your imaginations go wild. All right. The second part of your project is a dilation. This is where you need to look at your last rubric. If I took any points off on your floor plan, on your room measurements, then you need to see me, because we need to make sure those are correct, because this dilation and these room measurements are going to come into play at another date. So what you're going to do is you're going to take your little teeny tiny floor, you're going to do your bedroom and whatever room you were given. Not the whole house, just your bedroom and other room, and you're going to dilate it onto a sheet of plain paper. So right now you have 1/8 of an inch equals 1 foot. You might do a dilation by a factor of 4. You might do a dilation by a factor of 8. It's up to you. But if you multiply by 4, the 1/8 becomes a half, correct? So now a half an inch equals a foot. If you do a dilation by an 8, now all of a sudden 1 inch equals 1 foot. It's up to you how you want to do it. You could do a dilation of 2. So then make sure that when you go and after you do that dilation, that when you draw your bedroom, I don't want to see walls that look like this. Do you want to live in a house whose floor is crooked? I need perpendicular lines. So I'm not asking you for constructions. I'm asking you to draw kind of like most of you all did on the construction ones when you were supposed to construct. Are you with me? Any questions? Today is November 3rd, okay? I'm only here 1 day this week. I'm here after school 2 days next week. So that's the 10, 11, 12, 13, 14, 15, 16, 17. It's going to be due November 19th. Okay? Now, if you get it to me no later than November, it's the latest it's due. It's a Wednesday. Maybe we'll make it due November 20th. And if you can get this to me by November 19th. How many days did I give you last time? 1 day? I mean, before the deadline. So you don't really have time to fix it. Let's say you get it to me no later than November. End of the day, November 18th. Then I will give it back to you to fix. 6 people took me up on that option last time. If everybody had taken me up on that option, everybody would have had 100 on that project. It would have brought your quiz grades or your grades up and not down. So this is the deadline to get feedback on your project. After this, on project. After this, you turn it in and it is what it is. I also need a rubric attached. You must attach the rubric. Attaching the rubric is going to be worth 1 point. You can get feedback any point before November 18th. Please don't wait till November 18th. Please get it in sooner. Because if you get it in sooner, I could possibly give you more than 1 day of feedback. Okay? Any questions? The objectives are online. Please study. All right? If you want to pull your grade out of the canyon, so to speak, tomorrow's an excellent opportunity. So this homework assignment I will be collecting tomorrow, so you can study. You should have gotten the other review back. Yes? Did you get the other review back? So then we should be good to go. Yes? Oh, okay. Anybody else have the that practice for the retake quiz? Okay, the latest you can take that quiz is Friday. You can take that sooner if you so prefer. But if you do not get me your practice and you have a 75% correct, you will not be taking that retake quiz. And depending on how many people take me up on this will depend on whether I ever do this again, because it was very time consuming for me to prepare mine.